Polaris Industries LP presents Snowmobile Service Topics 1993. Contents of this video include Torque-O-Matic drive, Polaris hydraulic brake system service, ITS suspension adjustments, and Fox shock maintenance.
Clutch alignment and offset. Remove the belt. Remove the driven clutch mounting bolt, washers, and spacer. Install a clutch alignment tool. Gently slide the driven clutch assembly until it just contacts the alignment bar. What you will be inspecting for will be the alignment bar to be in contact with the rear of the movable sheave, and coming towards the front of the movable sheave you will see a 1/16 inch air gap. The clutch offset on the P85 system is 5/8 of an inch. It is achieved by adding or subtracting shim washers on the jack shaft. After alignment and offset has been achieved, install the steel bushing and has however many 5/16 flat washers are needed to allow driven clutch flotation. Flotation must be obtained to prevent side load on the roller bearings of the jack shaft. Reinstall the drive belt, making sure the drive belt is shifted all the way out on the sheave of the driven clutch. Another check is belt to sheave clearance of the drive clutch. You must maintain a minimum of 20 thousandths of an inch. Another adjustment is belt deflection. With reasonable finger pressure, pushing down with a straight edge line on top of the belt from the drive to the driven clutch, you should be right around 1 1/4 inch belt deflection. Another check that can be made is the belt outside circumference. Using a very narrow tape measure, wrap it around snugly to get an accurate reading. Nominal belt measurement of a 3211-042 drive belt is 47 1/4 inches. The other measurement is the width. The nominal width of the 3211-042 drive belt is 1 3/8 inches. Belt deflection adjustment on the Indy Storm can be achieved without disassembly of the driven clutch. An outer cam plate feature has been added. In this view, notice the excessive belt deflection, and also note the position of the belt in the sheaves. To obtain the correct belt deflection, loosen the 3 screws that secure the outer cam. Then position the belt deeper into the driven clutch. This will relieve the pressure from the internal pins that contact the adjuster cam. To decrease the distance between the sheaves, which in turn will allow the belt to ride out further on the clutch, turn the cam counterclockwise. Total adjustment from full left to full right on the new externally adjustable design is equivalent to 4 30,000 spacers, which are currently used on the present P85 system. Tighten the 3 screws to approximately 10 foot-pounds. Return the belt to the neutral position and check the belt deflection. As you can see, the belt deflection is now acceptable. Also notice after the adjustment where the belt rides in the driven sheaves. This feature is also available for all other models that currently use the P85 system. The clutch part number is 1322151. Driven clutch disassembly. Rotating the movable sheave counterclockwise and hold it to the stationary. Apply pressure to the helix and push downward. It sometimes may require that the helix be tapped lightly with a saw face hammer in order to achieve downward pressure. With the snap ring pliers, remove the snap ring. Let the movable sheave unwind slowly and remove the helix along with the washer, the spring, and remove the movable sheave. The washers between the movable and stationary sheave are used to adjust the belt deflection. They are each 30,000ths of an inch thick. Adding a washer will increase belt deflection. Subtracting a washer will decrease belt deflection. It is recommended to use no less than 1 washer. Inspecting of the bushings. The DU bushings, which is the large diameter bushing on the inside, requires change when 75% bronze is exposed. The bronze oilite bushing is not replaceable. It should be inspected with each disassembly. The driven clutch spring tangs should be straight in line. If not, adjustment must be made to an alternate hole in the helix. Prior to assembly, inspect the condition of the helix. The outer edge must be smooth and remain free from any burrs. Insert the helix into the movable sheave and slide back and forth, assuring free movement. Install the spring into the movable sheave. Position the spring into the desired hole of the helix and lightly compress it into the movable sheave. Install the movable sheave and the helix as an assembly onto the stationary shaft. Line up the keyways and install the key. Rotate the movable sheave counterclockwise 1/3 turn for proper spring preload. Install the washer and then the snap ring. Note, the opening of the snap ring must never be in line with the keyway. Drive clutch disassembly. Tools needed are a 3/4 inch drive torque wrench, 3/4 inch drive breaker bar, Polaris spider tool, Polaris jam nut tool, and the Polaris holding fixture. Prior to disassembly of the drive clutch, note the X's on the top of the cover. the spider, and the movable sheaves. These X's are to remain in line at all times to assure proper balance as the clutches are balanced as an assembly. At the same time prior to disassembly, mark the cover and the spider and the movable sheave and the stationary sheave in a straight line. Place the drive clutch in a clutch holding fixture. Remove the cover bolts. Remove the spring in the cover. With the Polaris jam nut tool and the 3/4 inch breaker bar, remove the jam nut. Notice, the jam nut is not used on all models. It is found mostly on the high-performance snowmobiles. Next, install the Polaris spider tool and remove the spider. When removing the spider, notice the number of washers that are installed beneath the spider. Remember that during assembly, the same number of washers must be used in order to obtain drive clutch balance. Remove the movable sheave and inspect the bushing. Inspect the weights and weight pins. You're looking for any side play or tail wag of the weights. Free movement up and down is a necessity. Inspect the stationary shaft. Inspecting both areas where the cover bushing rides and the movable sheave ride. Spider roller condition is best checked with a straight edge rolling back and forth on the bench. Rollers should roll back and forth freely. If a roller is found to be faulty, usually it will show discoloration or noticeable flat spots. Remove the buttons with the Polaris button tool. Place the spider on the vise. Using the large diameter of the Polaris roller pin tool, lightly tap the roller pin through the spider. The three parts that make up the leg of each spider are the two multi-lube washers, the roller, and the roller pin. For roller and pin installation, place the spider on the vise with the tapered end first, lightly strike the pin with the hammer. Protrude one end of the pin through the first leg of the spider about 100 thousandths. This will enable you to locate the first washer then the roller, and then the second washer. Place the Polaris roller pin tool through the opposite side large diameter first. This will act as a pilot when driving a pin through from the other side. Lightly tap with a hammer until a pin comes through the outer leg, and then center the pin. With all pieces inspected and ready for reassembly, install the movable sheave first. For demonstration purposes only, during reassembly, we will assemble 2 washers under the spider. Remember the X's and remember the marks prior to disassembly. With the extra washer, the marks do not line up. The movable sheave and the stationary are in an unbalanced state. To achieve balance, we will unscrew the spider once more and re-index the spider to the movable to try and achieve balance. Turning the movable sheave 1/3 turn at a time until balance is achieved. Also notice with the extra washer, after balance has been achieved, we have excessive belt to sheave clearance. It will be required that we remove one of the washers. Remember that the belt to sheave clearance should not exceed 20/1000ths of an inch. When the correct belt to sheave clearance has been achieved and the balance factor has been achieved, torque the spider to 200 foot-pounds. Install the jam nut and torque it to 235 foot-pounds. Install the spring in the cover, and in this torque sequence, torque the cover bolts to 90 inch-pounds. Now available is our clutch bushing removal and installation toolkit. Item number 1 is the P85 drive clutch bushing remover and installer tool. Item number 2 is for the P90 drive clutch bushing for removing and installing. It also installs the bushing for the P90 driven clutch. Item number 3 is the cover bushing removal and installation tool for all drive clutch covers. Item number 4 is for installation of the P85 driven clutch, the large DU split bushing. Item number 5 is the bushing removal tool for the P90 driven. Item number 6 is a tool for the P85 driven movable sheave. Item number 7 is a bridge. Number 8 is the main adapter. Number 9 is the adapter reducer. Item number 10 is adapter number 2. The kit has been incorporated to be used with the piston pin puller, which is the Polaris service tool, part number 2870386. First, install a piston pin puller securely in a bench vise, then lightly grease the puller threads. Install the main adapter with the P85 drive clutch movable sheave bushing installation tool, as shown. Install onto the puller and install the nut. Turn counterclockwise until bushing and retainer ring have been removed. For installation of the same bushing, start the bushing by hand. Install the tool as shown. Rotate the sheave counterclockwise until the bushing is seated. Install the retainer ring, and the same method applies. For cover bushing removal, some models use a round wire snap ring. Remove the snap ring with a small scribe or a pick. Install the tool into the cover bushing and install the cover onto the puller with the main adapter. Reversing the operation, install the bushing, then install the snap ring. P85 driven movable. Notice the split bushing. The removal tool must be installed to line up with the split. Install the larger diameter of the two ends towards the bushing. Notice how the split lines up with at least one half of the tool. Turn the main adapter around. Install the bridge. And with downward pressure, hold the removal tool so it remains tight within its radius. Install the sheave to the puller, adapter, and bridge. Install the nut. Slowly line and tension the removal tool. Turn counterclockwise until the bushing is removed. During installation, again know where the split is on the bushing. The split must be in line with one of the screw holes as the screw holds the bushing in place after installation. To start the bushing, lightly tap with a soft-faced hammer. Install adapter number 2 onto the puller. Install the installation tool for the DU bushing. Again, rotate counterclockwise until the bushing is seated. Notice the split in line with the retaining screw hole. For bushing removal of the P90 driven, it will be necessary for heat to be applied as the bushings are installed with Loctite. For removal and installation, a number of tools are required. We need a main adapter along with the adapter reducer and the bushing removal tool along with the bushing installation tool. Install the main adapter and the adapter reducer. Apply heat around the outside of the bushing until tiny smoke tailings appear. After heat has been applied, it will be required to wear some type of insulated glove for the rest of the removal process. Install the bushing removal tool. Install the nut and tension the puller and turn the sheave counterclockwise until the bushing is removed. For installation, use adapter number 2 and the P90 installer tool. Rotate counterclockwise until the bushing is seated.
In the following presentation, we will review hydraulic brake system basic operation, but more specifically the master cylinder's responsibility toward neutralizing and maintaining brake system pressure. The Polaris Snowmobile hydraulic brake system consists of the following major components: a handlebar mounted master cylinder and a brake hose connecting this cylinder to the brake caliper. This caliper contains a piston which moves outward when the brake lever is applied. As it moves outward, it contacts, on this particular model, the brake cooling manifold, which contacts the piston side brake pad and forces this pad against the brake disc. The fixed brake disc causes the caliper to move in its carrier bracket and pull the stationary side pad into the brake disc. The brake disc is fixed to the drive line, and with the brake lever applied, braking action begins. Let's take a closer look at the handlebar mounted master cylinder and its function. The brake lever, when applied, contacts and moves the master cylinder piston inward. Attached to the piston is a lip-type seal, often called a U-pack seal. When this seal closes or passes by a small compensating port, the fluid within the system begins to build pressure. As the pressure within the system increases, a square-cut seal within the caliper flexes and allows the piston to travel outward. When the lever is released, the seal moves to its relaxed position and pulls the caliper piston away from the brake pads, or the piston inward. Temperatures frequently change within the brake system, and as the temperatures change, the brake fluid volume and space requirement change. Warm or hot brake fluid requires more space than cool or cold fluid. To compensate for these normal changes in volume, located within the master cylinder is a small port. This compensating port, when open, will allow the fluid to normalize pressure. However, if this port is blocked, cool or contracting fluid may pull the caliper piston inward, causing poor braking action. If the fluid expands and the port is blocked, the caliper piston will be forced outward, generating more heat and more fluid expansion. When servicing or diagnosing brake problems, check the compensating port. Be sure the brake lever and piston always return to open the port. A piston or lever that does not return completely will block the port. Of equal importance to proper brake operation is correct fluid level. Too much fluid will not allow for fluid expansion, and pressure will build. And too little fluid will allow air to enter the system and cause spongy brakes. Also located within the master cylinder is the combination cover gasket and diaphragm. The diaphragm and cover keep outside air from entering the system and contaminating the fluid. During fluid expansion, the diaphragm moves upward and equalizes internal pressure. As the fluid cools, this diaphragm moves downward. Located in the cover are two small vent passageways. These vents allow the diaphragm to bellows or move freely. Always check the vent passageway and replace the cover gasket when servicing the master cylinder. In this short segment, we have covered basic brake operation, the importance of the compensating port, brake fluid level, and diaphragm, all related to maintaining consistent pressure during the changing brake system temperatures. Always reference your master repair manual for proper brake system overhaul. In this next video segment, we will cover the new brake caliper and additional brake service tips. Shown is the new chain case and brake caliper assembly. This brake caliper features spring plates to better position the brake pads and also reduce brake noise. This brake caliper design also significantly reduces the time required to service the unit. When servicing the hydraulic brake caliper, one of your final inspections must include a visual inspection to see that the piston retracts away from the brake pad when the brake lever is released. If this does not occur, the brakes will overheat. Shown here are the two new brake caliper assemblies. The unit shown on the left is the new liquid-cooled version. The top half of the unit is sealed to the caliper casting, and the coolant circulated through it takes away any unwanted heat. Available for these new brake calipers is an extended wear brake pad kit. This larger pad should be used when extended pad life is requested or required. Kit part number is 2200-459. All new style pad kits will include 4 pads, new spring plates, and detailed installation instructions. This concludes Brake Topics 1993. Thanks for your attention.
This portion will cover what's new for 1993 suspensions. The improved transfer suspension is unique to the 1993 production units and the 1992 XLT pilot build. All working components of the suspension are moved forward on the rail. Also, the location of the suspension tunnel mounting pads have moved forward accordingly. Therefore, the ITS will not retrofit any previous production units without tunnel modifications. The improved transfer suspension is much more responsive to driver position than ever before. With driver weight shifted forward, more ski pressure is applied. With driver weight shifted rearward, track pressure is increased, making it much more aggressive on acceleration. There is also an increased length of track on the ground. The ITS rear torque arm linkage has been changed to improved weight transfer. The ITS suspension is equipped with the rear limiter strap similar to the XCR. The rear limiter strap is set in the longest position from the factory and can be shortened to driver preference. The Storm ITS suspension has a unique longer front shock. The front shock spring is also exclusive to the Storms with a heavier spring rate of 160 pounds per inch. The increased rate will support the front end and keep it from bottoming in the rough. The Storm also comes standard with 4 additional bogie wheels. These wheels will increase Hyfax wear and track life. These wheel kits are available for all ITS and would be a definite plus for consumers in extending Hyfax and track life on marginal snow running. When installing wheel kits, the rear holes are available, however, the front will have to be drilled. The dimensions for drilling these holes are provided in the kit part number 2871073. It will require 2 kits per suspension. All wheel bearings have changed this year to NTN, which is an improved bearing. All triple-cylinder units with ITS suspensions have 4 rear idler wheels. The rest have 3. The 4th idler wheel kit, part number 2870-613, can be mounted on all 3 idler wheel ITS suspensions. The Storm also has 1.5-inch wide high-facts. This will improve handling and will lighten the load on the wheels. With the wider high-facts, track alignment is very critical. The wider high-facts can be used on all models with guide clips. The XCR suspension will require drilling high-facts mounting holes using the rail as a template. Wider high-facts in poor lubricating conditions may require dipping the high-facts in snow more often. Here again, adding wheel kits will improve this condition. As in the past, the rear springs are the main load-carrying component of your suspension. There are eccentric adjusters on each spring which give you 3 different positions, soft, medium, and firm. These adjustments can easily be made by using the spark plug wrench provided in the toolkit. Remember, ski pressure will change with spring adjustment. Adjusting to stiffer spring rate will increase ski pressure. Therefore, it may become necessary to lengthen the front limiter straps to carry more weight on the suspension, which will lighten the steering. The front shock has 2 upper mounting positions. The rearmost will give the more firm ride. Along with adjustability, Polaris has 3 different spring diameters for a more driver-tailored ride. The springs are exclusive to the ITS suspension. Available wire diameters are 406 thousandths, 421 thousandths, and 437 thousandths. See the MRM, Section 9, for the spring part numbers. For your information, the 440 and 440 SKS has a 406 thousandths wire diameter standard for 93, while all other models with the ITS come standard with the 421 thousandth diameter wire. 1993 Fox Shock internal floating piston maintenance. Changing oil on Fox Shock is recommended annually and must be done when performing your season end storage preparation. This oil change is necessary to avoid a chance of corrosion that can be caused by moisture contamination. When doing the maintenance on the Fox Shocks, use the gas shock recharging kit, part number 2200421. It consists of the necessary valves, pressure gauges, and fittings to deflate and pressurize the shocks. Not included in the kit is the body cap tool, part number 2871071, which is necessary to hold the shock body when disassembling. Warning: extreme caution should be observed when handling or working with high-pressure service equipment. We strongly recommend that you wear safety glasses and ear protection during servicing of your shocks. Care should be observed when handling the inflator needle and the pressure gauges. Maintain your equipment and keep it in good condition. If injury should occur, consult your physician immediately. Extreme cleanliness is of the utmost importance during all disassembly and assembly operations to prevent dirt and foreign particles from getting into the shocks. Thoroughly wash the shocks in a parts washer and or with soap and water. Then dry with compressed air to remove sand, dirt, and other debris. Position and clamp the body cap of the shock in the soft jaws of the vise. Remove Allen screw from the air valve located in the body cap. You will need a Fox safety needle to depressurize the shock. This safety needle is included in the kit. Assemble the depressurizing valve to the pressure gauge fitting and tighten securely. Then turn the T-handle valve clockwise to open the spring valve assembly. Assemble safety needle to the pressure gauge and tighten securely. With valve outlet pointed in the safe direction, insert safety needle assembly into the pressure valve. Do not release nitrogen except in a safe direction away from everyone. Depress safety pin and push valve assembly down, inserting needle. When pressure gauge shows 0, shock should be deflated. If pressure will not release, check the fit of the safety needle to the shock valve housing. It should be flush. If not, it may be necessary to modify the safety needle tip to allow insertion. File the knurling of the red tip off to allow insertion. Extend the shock shaft by pulling up on the shock eyelet. Using a 1-inch wrench, unscrew the shaft bearing cap. Note, if the body of the shock starts to unscrew from the body cap, retighten and try again. It may be necessary to use the body cap tool clamped lightly around the body and the soft jaws of the vise just above the body cap to hold the shock from turning. Pull shock rod and piston straight out to avoid seal or valve damage. The piston ring may fall off as you do this. Be prepared to catch it. Dispose of used oil properly in a suitable container. Rinse cylinder and piston assembly with mechanic solvent or equivalent and blow dry with compressed air. Set aside piston assembly for reinstallation later. Using the body cap tool, part number 2871071, position the tool just below the body cap and carefully tighten in the soft jaws of the vise. Caution: never apply heat to the shock body without first depressurizing the shock and removing the bearing cap and oil. Lightly heat the threaded area of the body cap with a butane torch to loosen the Loctite sealant. Note, do not overheat or you could cause damage to the internal seals or cause personal injury. Using a large adjustable wrench on the body cap, unscrew the body cap from the body. Note, parts are hot. Use leather gloves to handle the parts. Remove the internal floating piston by pushing it out with a hammer handle toward the body cap end. Be prepared to catch the piston as it comes out. Notice location of the Allen screw for reassembly in the body tube. Remove the Allen screw and O-ring from the center of the piston. Inspection of all parts. Carefully clean all parts thoroughly in a parts cleaner and dry with compressed air. Inspect seals and shaft surfaces for any damage. Reassembly. Wrap flexible piston ring around dampening piston and reinstall in the body. Lightly tighten the bearing cap into the body with a 1-inch wrench until the bearing cap and O-ring seal are seated. Fully extend the shaft and mount the shaft eyelet in the soft jaws of the vise, body end up. Slowly pour 5-weight suspension fluid, 2870995, into the body of the shock until it comes within 3/4 of an inch of the top of the body. Slowly stroke the shock several times, moving it up and down to bleed any trapped air in the valving. Remove the shock from the vise. Reposition and mount the flats of the bearing cap in the soft jaws of the vise and lightly tighten. Do not over-tighten or you may crush or deform the bearing. Wrap the flexible piston ring around the internal floating piston and insert into the body O-ring first. Slowly position the IFP to specified piston depth. Note the IFP must be within 50 thousandths of the specified depth. Refer to the illustration in the MRM for the IFP depth of the appropriate shock. Slowly bleed the shock once more by pushing up and pulling down on the shaft eyelet to fully extend the shock shaft. Caution: oil should squirt out of the IFP bleed hole during this procedure. If oil does not come out of the bleed hole, add more oil through the bleed hole to bring it to full capacity. Also be sure to double check the IFP depth after this procedure. The IFP should be completely submerged in fluid at this point. Reinstall the screw and O-ring in the center of the piston using a 1/8 inch Allen wrench and tighten. No oil should be left on the piston top, therefore pour out excess oil and with a clean, dry, absorbent shop rag, remove any excess oil. Make sure no lint or other debris is left in the piston area after removing the excess oil. Verify the IFP depth once again. Thoroughly clean the external threads of the body with Loctite Safety Solvent 755 and apply red Loctite Sealant 277 to the first couple of threads. Do not apply Loctite to the internal threads of the body cap. Now install body cap and hand tighten. Mount the shock body cap end down in the soft jaws of the vise. Torque the bearing cap to 8 to 10 foot-pounds. This will also tighten the body into the body cap. Do not over-tighten or it may cause damage to the bearing. Using Fox shock safety needle valve installed on the pressure gauge assembly, pressurize with nitrogen gas to 200 psi. Once pressurized, the shock will not read 200 psi if checked. It should read approximately 150 psi. This is normal due to gas volume displacement in the gauge assembly. Reinstall the Allen screw. To test the shock for smooth and consistent dampening, place the shock eyelet on a hard surface and fully compress the shock, then let the shock return. Shock should offer obvious, consistent dampening, moving freely through both the compression and rebound strokes. Now you are ready to reinstall your Fox shocks. Note: the front torque arm shock is of the welded dome type, therefore you will need to refer to the 1992 Fox shock video for maintenance procedures. Thank you for your attention.